If you've been seeing LangChain and LlamaIndex everywhere and feeling a bit overwhelmed, don't worry. In this video, we'll compare them in a practical way. Not by hype, but by asking a simple question. What problem does each tool solve best, especially for RAG applications? AI tools are coming out so fast that trying to master all of them is honestly exhausting. A better approach is to understand what each tool is good at, what problem it solves, and whether you even need it in your stack. That mindset makes comparison much easier and much more realistic. Both LangChain and LlamaIndex appear in modern AI stacks, and yes, they overlap, but their strengths are not exactly the same. LangChain is usually preferred for complex chaining, tool use, and agent orchestration. LlamaIndex is often stronger when the main challenge is connecting data, structuring information, and improving retrieval quality. RAG stands for Retrieval Augmented Generation. Instead of forcing a model to memorize your company policies or FAQs, you connect the model to your actual data. When a user asks a question, the system first retrieves relevant information from current documents, then the LLM uses that context to generate a more accurate answer. Now let us look at this in a simple table format.
LangChain vs LlamaIndex.
Main practical difference in RAG projects. Here's the simplest practical comparison. If your project is mainly about agents, multi-step workflows, and calling tools, LangChain is usually the better fit. But if your main problem is organizing data, retrieving the right context, and improving RAG performance, LlamaIndex often has the edge. Imagine an e-commerce website with refund and return policies. In older systems, you had rigid rules or intent classifiers, and every policy change meant manual updates. With RAG, the chatbot can pull the latest answer from FAQs, legal pages, or internal docs. That makes the system more flexible, easier to maintain, and more useful to customers. Now that we've covered code comparison, let's test what we've learned so far.
Here's quiz number 1. See if you can get it right.
Question 1. Which tool is more commonly preferred for complex agent workflows and tool orchestration? The correct answer is LangChain. The article positions LangChain as stronger for chaining, agent workflows, and tool orchestration. Question 2. In a RAG system, what happens before the LLM generates the final answer? The correct answer is relevant context retrieval. RAG first retrieves relevant snippets from documents, then the LLM generates the answer using that context. Question 3. What is the smarter way to evaluate new AI tools? The correct answer is match tool to problem. The article's main message is to stop trying to learn everything and instead understand what each tool is actually good at. A basic RAG application usually follows a few simple steps. First, data is indexed. Then, when a user asks a question, the system retrieves the most relevant chunks. Finally, the LLM generates a response using those retrieved chunks. In practice, teams also evaluate retrieval and generation quality using metrics like precision, recall, MRR, and NDCG. Now comes an important part: indexing. Technically, you can store all vectors and compare a query with everything. That is called a flat index, and it can be accurate, but it becomes too slow for real systems. So vector databases use indexing strategies that reduce how much of the dataset needs to be searched. 3 common indexing techniques are LSH, IVF, and HNSW. LSH pushes similar vectors into the same buckets, which works better for smaller or lower dimensional data. IVF divides the space into regions around centroids and searches selected cells. HNSW builds a multi-layer graph, giving fast search and high recall, though it usually needs more memory. This is where LlamaIndex becomes especially interesting. A vector database helps you find nearby points, but LlamaIndex helps organize how information is structured and navigated. With ideas like tree index, graph index, and summary index, it can use hierarchy relationships and summaries to improve retrieval instead of relying only on similarity search. Now that we've covered RAG and indexing, let's test what we've learned so far.
Here's quiz number 2. See if you can get it right.
Question 1. Why is a flat index often avoided in production systems? The correct answer is, it is too slow. A flat index checks everything, so it becomes slow as the dataset grows. Question 2. Which indexing method organizes vectors into cells around centroids? The correct answer is IVF. IVF splits vector space into cells around learned centroids and searches selected cells. Question 3. Which framework is highlighted for structuring data and controlling retrieval more intelligently? The correct answer is LlamaIndex. The article emphasizes LlamaIndex for hierarchy, structure, and retrieval control. Let's make that practical. If a user asks for general refund policy, hierarchical organization helps the system go to the right level instead of pulling random chunks. If the question involves relationships, like shipping delay affecting refund eligibility, graph-based retrieval becomes useful. And when you have many manuals or documents, summary-based filtering can narrow the search before deeper retrieval happens. So the answer is not really which framework is better overall. The better question is, where is your bottleneck? If your challenge is agent logic, multi-step workflows, and tool calling, LangChain makes a lot of sense. If your challenge is data organization, retrieval quality, and context-aware search, LlamaIndex may be the better choice for your RAG application. Now that we've covered final decision, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. If your main bottleneck is retrieval quality in a RAG app, which tool is often the stronger choice? The correct answer is LlamaIndex. The article presents LlamaIndex as stronger for data structuring and retrieval-focused problems. Question 2. Which index type is known for high recall and fast search, but higher memory usage? The correct answer is HNSW. HNSW uses a multi-layer graph and usually offers strong recall and speed, with a memory trade-off. Question 3. What is the most practical takeaway from this comparison? The correct answer is pick based on your bottleneck. The article's core advice is to choose tools based on the actual problem you need to solve. If this made the comparison feel less confusing, great. The AI stack will keep changing, but your evaluation method doesn't have to. Stay practical, stay problem first, and you won't lose your mind keeping up.